Welcome to Infinity QS's Tales from the Trenches. In this video series, we present real-life quality professionals discussing how they solved important quality and process problems at their facilities. These quality professionals get into the details and they show us how they leveraged Infinity QS software to solve their problems, including how they identified root cause. Accurate and timely data is fundamental to any successful quality program. And in today's episode, Quality Manager Ian Farrell will discuss methods that he used to improve data collection efficiency, accuracy, and data analysis results. We hope you enjoy the video.
Hi, I'm Ian, and for the last 18 years, I've worked as a quality manager in the food and manufacturing industries. In this Tales from the Trenches episode, I want to show you how I improved existing data collection projects to reduce data error entries, yielding better data analysis, improved efficiency, and ultimately a higher quality product for my consumers. By putting in a little bit of front-end work to prevent data entry errors, I'll show you how you can save exponentially more work on the back end performing manual data cleansing. Finally, I want to show you how I used Infinity QS SPC software as a tool to collect accurate data, improving turnaround time on product quality and process efficiency decisions. Knowing the right data to collect and the right way to analyze it is critical. Without a focused, intentional data collection process, you can end up with a lot of data, but nothing very useful. Because of this, a lot of effort is put into building data collection and analysis systems. In manufacturing today, there isn't time to reinvent data collection and data analysis for every new roadblock. Efficient manufacturing relies on a quick turnaround from data collection to data analysis to process improvement. As we've all seen, the expectation is that this continuous improvement cycle be repeated time and time again, each time faster and more efficient than the last. Because of this expectation, it's important that quality professionals work to streamline our data collection and data analysis so we don't become the rate-limiting step in our company's DMAIC cycles. In all the years I've been in manufacturing, I've never had extra time to perform data cleansing while the team waits for me to complete a root cause analysis or process improvement. On the contrary, the analyze phase of a Six Sigma DMAIC process is often the most frustrating for action-oriented manufacturing professionals. Where define, measure, improve, and control are active, collaborative, and decisive routines, analyze is much more passive and often relies on one person or a small team working with data sets in software such as Minitab or Excel. If you've never had the experience of having your plant manager sitting in your office, impatiently waiting while you analyze a set of data, consider yourself lucky. If you have had that experience, you know the last thing you want to do in that situation is add extra time by manually sorting and cleansing the data you're working with, especially with an audience like that. Another situation I've seen, and hopefully one you've not had the pleasure of experiencing, is pulling up an automated report in a meeting only to find that the data entered since the last time you pulled it up is clearly erroneous. I've seen horribly skewed graphs. I've seen auto-scaled y-axes so large that your spec range seems like it's only a few nanometers wide on the screen. And sometimes I've seen graphs that are just blank, leading to equally blank stares from my coworkers. All these scenarios are easily preventable, and with just a few easy tips and tricks, you can go from data goat to data guru. When thinking about data entry errors and the resulting delays and embarrassment they can bring, I have a couple scenarios that come to mind. The first type of data error I want to relate to you has to do with recorded data that has to be weight corrected, like measuring defects per pound. When a defect is either plentiful or rare, the sample size won't necessarily match up with the units the defect is reported in. For instance, take the dreaded unpopped popcorn kernel. It's a really rare defect, so sampling just 1 pound of popcorn is statistically unlikely to have any unpopped kernels present. As a result, 5 pounds of popcorn must be sampled to get a statistically valid measurement. The resulting count is then divided by 5 to report the results in the units of defects per pound. Another way to think about the problem is a plentiful but time-consuming count. Inclusions in cereal, such as raisins, need to be counted, but the counting takes a long time. Counting the raisins in a pound of Raisin Bran could be a full-time job, so a smaller sample is taken and multiplied to get the raisins per pound value. When a test result has a simple calculation as part of the test, operators can often do the math in their head rather than relying on the calculation features built into software such as Proficient or Enact. When the data is entered, this can result in a doubling of the correction factor and in values that not only don't make sense, but can lead to erroneous data analysis and incorrect process improvement decisions. In another situation, a simple mix-up between metric and standard units can not only cause data analysis errors, but when coupled with automated reports, I've seen it generate certificates of analysis that show good product as being out of spec. Now, this is not as critical as when NASA crashed a Mars probe by mixing up their units of measure, but I would not use that as an excuse when your boss asks you to explain why a customer received out of spec product. In all of these situations, where time was of the essence, the delays were due to a reliance on data cleansing instead of utilizing the benefits of proactive error proofing. Known by a variety of names, the concept of mistake proofing has been around for a long time. Mistake proofing aims to first prevent defects from occurring, and if that's not possible, it aims to detect defects upon occurrence. In 1960s Japan, Shigeo Shingo applied the name Poka-yoke to quality assurance. Translated literally, this became known in the English-speaking world as mistake proofing. Frustrated by operators forgetting to install a spring into the small electrical components they were building, Shingo realized that if he modified the workflow, the lack of the spring would become immediately apparent to the operators, resulting in a drop in defective switches. This same principle of a physical barrier to mistakes, or an automatically triggered warning notification, has become pervasive in manufacturing. From the two-handed operation of a machine press to prevent hand injury, to the designing of jigs that only fit in a specific orientation, error proofing shows up throughout factories across the world. From a quality perspective, error proofing supports a reduction of defects and a transition from quality control's reliance on final inspection to quality assurance's built-in quality and zero defects mentality. With the help of electrical sensors, PLCs, and computer software, the principles of Poka-yoke continue to expand in their applications within the manufacturing sphere. Infinity QS software solutions make it easy to error-proof the data entry process. In Proficient, from the specification window, you can input reasonable limits to your data collection. The software will even suggest reasonable limit values for your data, but you're free to manually input your own values. After that, check the box to trigger an alarm upon violation and you're all set. Now, whenever an operator enters data for that part test combination, the system automatically confirms that the data is within the reasonable limits. Any data outside those limits brings up a warning screen asking the operator to confirm or correct the suspect data. With reasonable limits enabled, your data is now much more reliable. Gone are the struggles with charts attempting to auto-scale to fat-fingered results. No longer will you be spending your time checking your data line by line, looking for that one entry of 1,250 grams in a long row of 1.250 gram results. Just like Shingo's spring insertion solution, you're shifting your quality efforts further and further upstream in the process, catching and correcting defects in real time, not with added labor after the fact. Another nice feature of reasonable limits and error proofing your data is that it's a win-win for you and your operators. Whereas some of the other topics we've presented in Tales from the Trenches require finesse to get operators on board, I suspect you'll find operators will be happy to have this feature enabled, serving as an easy double check to their data entry. With reasonable limits, there's only upside. Professional embarrassment and a duplication of effort are both powerful motivators for process improvement. Because of this, the decision to enable reasonable limit detection on our processes was truly a no-brainer. Remember the calculated test results for unpopped popcorn and the operator's tendency to perform the calculation in their head? In yet another instance of error proofing, we were not interested in removing the automatic calculation features from our data entry configurations. Sure, the math was easy, but each calculation given to an operator versus a computer is just another place for data errors to occur. Rather than solve the problem by removing error proofing, we doubled down, utilizing both the calculation and reasonable limit features in our Proficient implementation. After that, when an overachieving operator did the math in his head or found a stray calculator in the lab, they were greeted with a bright red warning on their data entry screen, asking them to confirm or correct the value. By utilizing all the layers of error proofing Proficient has to offer, we saw improvement from data entry through to data analysis and into process improvement. Proficient can make error proofing much easier to implement in your quality program.
We hope this episode of Tales from the Trenches has shown you ways to improve data collection when using InfinityQS software at your company. InfinityQS is always there to help. We have application engineers ready to assist you in getting the most value out of your InfinityQS implementation. Reach out to your sales representative for more information and pricing. Thank you for watching, and check back soon for our next episode of Tales from the Trenches.